So example 4 takes all these rules together, or maybe most of the rules together, I don't know. The one thing that's not going to happen in these problems is the negative power issue. Okay? I don't know if A is positive or negative, so it doesn't matter if there's a minus sign on it. Okay? If A is a negative 4 and it says negative A, then that's actually positive 4 power. So it doesn't really matter. I'm going to create an expression that's always every letter in the numerator raised to a power for a final expression. I don't want to have like x over y or anything like that for a final answer. Okay, so the technique is what it always has been. We deal with the power to a power issue first. Always deal with that first. So if I deal with this, x to the a to the b, the rule tells me I'm supposed to multiply a times b. That immediately gets as simple as possible. If I got y to the a to the b plus 2, I'm supposed to multiply a times b plus 2. I could over here do a times b plus 2 and just distribute it. ab plus 2a. I'm fine if you go ahead and get a simplified expression immediately on these. Again, you got several steps anyway, so you're going to have a chance to show a lot of work. All that goes over x to the minus a. And I didn't use a special color on that one because I didn't do anything to it. Right? It just stayed. So as I'm evaluating this structure here, this power to a power structure, and I fix those out as much as I possibly can, anything that doesn't look like that, just move it along. Right? It's still part of the expression, it's still important, but we didn't do anything to it, so just bring it down. Okay. Once you apply that rule, the one that says that if you have x to a power equals x to the product of the powers, once you apply that rule, notice there's no parentheses on this side. Get the parentheses out of the problem. All right, so now you're looking at an easier expression. Next thing you want to look for is if x is being multiplied by x, or y is being multiplied by y, or w is being multiplied by whatever letters are in the problem. If you have the same letter being multiplied by itself on either the top or the bottom. So looking at the top, do we have the same letter being multiplied by itself?
No.
No. The bottom? No. So that's the next thing we look for. It didn't happen, move on. If it does happen, fix it. So if this was x to the ab and the x to the ab plus 2a, then by all means make the x's into 1. So do that step and apply it. But again, that's the next thing you look for. If it's there, deal with it. If not, move on. The final thing we look for is x to the m over x to the n. If we see that, we're supposed to subtract powers, and that is happening, right? We've got an x on top and bottom. So now we apply that rule. So we have to focus on the x's. The rule tells me I'm supposed to take the top power, ab, and subtract the bottom power. The bottom power is negative a. Again, I'm simply applying the rule. The rule says this, top minus bottom. The bottom is negative, but again, you subtract the bottom, so minus negative a. Right? And then notice the y is just the y, right? So nothing happened to that. ab plus 2a, can't make that any prettier than that. So the final step then would be to simplify the expressions if possible. Can that be made prettier?
Yeah.
What it would be?
X to the ab plus a.
Plus a would be better than negative negative a, right? Or minus negative a, whatever, however you want to read it. So two minuses makes a plus. X to the ab plus a is prettier than x to the ab minus negative a. Y to the ab plus 2a has been as simple as it could be since the first step, right? And just like that, we've got the final expression simplified as much as possible. X to some power, y to some power, both powers simplified. That's where we want to go on every one of these problems. Focus on structure in that specific order. Deal with that structure first, multiply the powers. That structure next, add the powers. That structure finally, subtract the powers. And again, I don't care about negative powers in this when they're abstract. It's always x to a power, y to a power, everything on top, nothing in the denominator. That's how I want your final answer to be written every time.